The only downside of when I go live on YouTube is that I lose control of the. Hi, everybody. Thank you for joining us today. Just give us a minute. Just trying to just get everything else completed. That way we could start our presentation today. Jorge will be taking care of our questions and comments on the YouTube page. Jorge, thank you so much for joining us. Greatly appreciate it.
Hey, how you doing, Ed? How's
Hey,
everything going
doing great,
today?
man. How's it been, man? How's everything back home? Everything okay? Everybody safe?
Everything good. Everybody's safe.
Excellent, man. That's awesome. Great to hear.
Here we go, live
Okay,
now.
very well. We're going to go ahead and start like in a minute or so. So let me just
Mm-hmm.
get the clock ready. That way, those that are joining us today can just go ahead and get settled. That way, they could start up with us. The Fusion 360 team, including Jorge and myself, we're doing webinars every day of the week. It's part of the program that Autodesk is doing. That way, you could learn more of Fusion 360 and all of its capabilities. And actually, just today, I had to consult some of our experts because we did get some questions about CAM today.
Nice.
I'm I'm not the strongest mechanical engineer, not even close to it, but I have a little better idea what CAM is, which is kind of neat. So make sure that you go to the Fusion 360 channel, YouTube channel. That way you could join us for our webinars every day. And Jorge and I were doing one tomorrow. And the one we're doing tomorrow, we're going to be talking about the different panels that show up in your schematic and on your board. Actually, they show up in the library as well. And the design manager, the device manager, um, the filters as well as. So we're going to be going over a lot of that. So I think it's time for us to go ahead and begin. So I'm just going to stop, go ahead and jump over to Eagle. That way we could talk about what we're going to do today. Okay, so let me go ahead and launch Eagle. I have it right here. So in today's webinar, we're going to be primarily working on creating your manufacturing files. That's what we really want to do today. We just want to have teach you. You're going to be learning today exactly what are the steps that you should be following to create your manufacturing files. Give me 1 second. I'm getting a little feedback, and it's because of the echo on the YouTube channel. So let me just disable it really quick. Okay, there we go. Excellent. Yeah. Yeah. I was getting a little bit of feedback from the YouTube channel. It was like in the back, my my earphones.
Yeah, that's why I always
Well,
keep it muted because it'll throw us off.
yeah, it throws you off because it's on a slight delay, so it just throws you off just a little bit. Well, welcome everybody, and thank you for joining us today. My name is Edwin Robledo, part of the Fusion Tech Marketing and Support team, as well as Jorge Garcia. Jorge Garcia is our evangelist, part of the evangelists and community managers. So you'll see a lot of his presence on the forum as well as sharing some design tips and designs that are actually used in the community. So thank you so much, Jorge. Will be primarily working on the chat and correcting me whatever I do wrong, which is quite often actually. So with no further ado, let's go ahead and start our webinar today. You know, We've been talking a lot on the first two webinars about creating your schematics and creating your circuit boards, and that's worked out really well. So we went through just creating a schematic with like had like six parts and creating the board, and we did some layout on the board, manual routing, auto routing, a quick routing, polygon pouring, and so forth, moving parts around, flipping them from top to bottom, and so forth. But today, let's talk a little bit more about manufacturing. I'm going to be covering primarily two examples. It's going to be the two layer and a four layer examples. As you know, this is the control panel that opens up every time you launch Eagle. You're going to see that there's a notification letting you know that there's a new update, which apparently I have not installed as of yet. Um, so let's go ahead and start loading our first board. So we have this example board that was provided to us by one of our users. It's actually a guitar pedal. I'll load the board as well as the schematic, as you can see. First thing I like to advise is, first of all, make sure, even though it's obvious here that I have it activated, but make sure that you have the settings to auto detect board outline. The screen line that you see right here is on a layer called the dimension layer. And that layer is the guidelines in which is going to confine where your circuit board is going to be, where all your parts and your routing should be located. So the first thing I like to do is click on options, select user interface. You'll notice that right here, there's an option that says detect board shape. This is extremely important that you actually have this, especially if you're going to be working with Fusion 360, if you're going to do some interaction with Fusion 360, that way you get your 3D models and maybe actually create an enclosure for it, or you have an existing enclosure, you want to make sure it actually fits. All of that, you need to start with the basics, and this basically there. Make sure that that option is selected. So it's really important that you have that available. The next thing I like to check is check your DRC. It's really important to go to your design rule checks to make sure that your board is manufacturable, that it has followed the guidelines that you have set, or the guidelines that you maybe have downloaded from a board house, to make sure that they are able to make this board that's manufacturable. So let's go ahead and go over to DRC, and the DRC is right here. Okay. Okay. And the first thing I want to do is check how many layers I have for this board. What's my layer stack up? So I'll go ahead and click on layers. And this board is just consists of two layers. So we have the top layer and the bottom layer. As you can see, it's a top and bottom layers, two layers set up. So you have three confirmations: the formula, as well as the drop down menu, as well as the graphic here letting you know that is a top and bottom layer. You have your layer thickness, which is typical, is 1.57 millimeters. That's just the way it is. And of course, since it's a two-layer board, we only have a through-hole vias that are going from the top layer all the way to the bottom layer. Now you have your clearances and your distances and so forth. We talked about this on earlier webinars. So I'm going to go ahead and click on check and just see if I have any errors that actually, usually I do have errors. It's just any errors that I need to be concerned about. So we got some angle errors here, which usually could be ignored. Okay, we got some, see, you got some angle errors there because the way it went in. So those are could totally be ignored. We have some drill sizes. The drill sizes is basically just letting you know that these drill sizes are smaller than what you expected to use. Depending of the application, you could go ahead and ignore these, or just go ahead and go ahead and change this as well if necessary. You could either change your DRC settings, that way you're able to accept smaller drill hole sizes, or actually edit these holes and make these vias with bigger drill hole sizes. Okay. So those are total. All these are can be ignored. So I'm not really concerned about these errors. Now the next thing you like to do is run your manufacturing. That way we take a look. It's kind of a preview of what my board is going to look like when I receive it in the mail. It's always a really good idea to do that. So let's go ahead and click on manufacturing. And you'll see we get a manufacturing preview of the circuit board. Okay. So this is what it looks like on the top side. Remember, this is a guitar pedal. So here's what it looks like on the top side. And let's take a look at what it looks like on the bottom. Okay. So you got your plated through pads and your vias as well. Let's see there. The green material, remember that's your solder mask. It's Here is a little tip in case you didn't know this. If I go here to configure my preview and I change my solder mask color, let's say we go kind of Osage Parkish, something like that. This color that you see here, if I was to push this over to Fusion 360, this color will actually be totally respected. So in Fusion 360, you'll see up the board will come up in purple as well. Now there's a lot more information there here we could take advantage of. So you'll notice that there's multiple tabs in this preview window. One is for boards, one is for drills. Let's go ahead and evaluate what the drill one has to say now. Okay, so I'm getting a comment that my volume is a little low, so I'll go ahead and raise it a little bit, Fox. Okay, very well. I raised my gain a tad. See if that helps. Now, on the tab here that says board, you'll notice that you have many drop-down folders here that show up that provide you a lot of information. So I'll just go ahead and expand the one called routing. You'll notice that it tells me how many signals I have. These are statistics on your circuit board, which are really interesting to know. Eagle will generate a report with these as well in the parts list. We'll have some of this information, not all of it. But here you could get the proper statistics. If you're for the board house, they may be asking you for some of this information, or you could just go ahead and add it to a report if required to. So as you can see, we have 122 signals. It's not that dense of a board. It has a total. This is primarily a through hole board. This is a very robust type of design. It's a pedal, so it's a real robust design. So as you can see, it has a total of 439 holes, and of those 439, 7 of them are non-plated, and the 432 are plated holes. Okay. Here are our pads. So components, we have 47 pads on the top. So this board is primarily is on as a top layer. It lets you know how many components that you have on the top as well as components on the bottom. There's only 2 of them. I think it's the battery and another component. Everything else is on the top layers. And it lets you know our stack up, which we already have verified. It was a 2-layer stack up. Okay. And here's your layout for your holes. So it lets you know, gives you kind of a map or legend about the plated through holes as well as your non-plated through holes. Okay. Now, if I wanted to export some of this information, I can, yes. Oh, actually, this information will be part of your output. So if I wanted to export this information, I could do it right here, as you could see, as a character right there. Oops, let me change that. Okay, right here. This is where you would export this information, either as a JSON file, as a character divided file as well, which can be easily imported into Microsoft Excel. Okay. Now let's go over to the CAM processor now. There's 2 ways you could execute the CAM processor. If this is just a straightforward board, 2 layers, nothing else has been done, you can use the OneClick solution. That's how I'm going to start off. I'm going to start better. I'm going to start with the OneClick solution that we have here. So I'm going to go ahead and click right here. It says generate CAM data right there. That's just a one-click solution. Let's see what we've done so far. And it brings up this dialog box letting me know what's going to be created. So let's do some observations here. First of all, you'll notice that it says it's a 2-layer template is what it loaded. That is correct because this is a 2-layer board. So when this is going to be executed, it actually takes a look at your layer stack up in the DRC and it loads the appropriate template for it. The file is actually going to be zipped up. You can see right here. It's just letting me know it's going to zip up the file. So you're going to end up only with 1 file. All of the Gerber files will be located in the same directory wherever your design is located. Whatever that folder that is, it's going to put them there. Now, this very, very first file that you see here, that's the job file. You see, this is going to be running a routine that is going to generate all your Gerber files. Now, remember, Gerber files is not 1 file. It's many files. So you have your top layer combined with your pads and VIAs. You have your bottom layer combined with your VIAs. And before I go and do this, I'm going to show you how does that look like. Gerber files is not 1 layer. It's not one file, it's many files, depending of the combination. I'll go here and click on the display command. That way you see what I mean here. I'm going to hide my layers. So my top copper, what my board is going to look like on the top copper when I send this to the board house is like this. This is my top copper layer. And that's my first clad. Then I'm going to generate another Gerber file. Actually, let me run rat's nest. That way the polygons are calculated. That way you get a better view. Also, there was just one polygon over here on the side. So not look that different. Okay.
Yeah. And one thing to keep in mind here, as nice as this is, it has limitations. It's making assumptions about your board. As you guys saw, it calculated looking at the DRC that it's a 2-layer template. But on a template like this, if you have anything like on a milling layer, or you have anything on a special layer, something that's unique to the design, you can't use this simple one-click method. But we'll be talking more about that as we carry on. But it's important to be aware of that. As long as there's nothing,
Yeah.
no special layers being used or anything with milling going on, you can use this.
Yeah. So something like here where you see the measurements or document or reference layer, those layers when you're using the one-click solution won't be taken in account. It's just going to go straight forward two-layer stack up, which is the regular layers, your T names, your B names, and just the regular layers that I used. Okay. Now this is what the Gerber file is going to look like on the top. This is what your Gerber file is going to look like at the bottom. And I'll just do one more. And this is in essence what your layer is going to look like for your silk screen. That's basically what your silk screen is going to look like. Okay, so let me cancel out of that. Just wanted to show you that because we're going to be able to preview that in a minute. So let's go ahead and go to the one-click solution as we were doing. So the first one is the job file. That's not actually a Gerber file. It's just a file that is created that has, it's an ASCII base file, which the CAM processor is going to export. And it has all the instructions, these instructions to generate your Gerber files. Pretty straightforward file. That file doesn't not need to be sent to the board house, even though they know when they see it, they're going to recognize it, but it's not necessary to send it to the board house. Now, if you have somebody else that is going to be generating your Gerber files and you want them to use the exact same format that you're using, and then you can share that file and they can load that into the CAM processor. Okay. Now we have our copper top layer. Oops, wrong one. Got our top copper, we got our bottom coppers, we got our board outline, and everything else that we have here. All these GBR files that you see here are our Gerber files. And then we have our drill output, which is the XLN. In this case, I only have vias that have one depth. It's from the top layer to the bottom layer, so it has 1 through 16. And then we have our bill of materials, and then we have our pick and place for the front and our pick and place for the bottom. I'm going to go ahead and click OK. Go ahead and click OK. And it's asking me where do I want to put those files. I actually want to put them right there where they're going to be located. It usually will default to the path wherever my board is located. That's where it will always default, and I do want them there. So I click on save. Okay. So it opened it up. It opened up the file manager on my other computer, on my other monitor. So here it is. There's the zip file that got created, as you can see there. I'm just going to go ahead and unzip it. That way you see what files were created. So now I could go ahead and email this to a board house. That way I could get a quote. Or there's many board houses that you could just go to their website and upload this file. That way you could get a quote for it, okay? So let's double click it. That way we uncompress it. You'll see that it created a subfolder called CAM Outputs. And we have here our assembly, which is basically, this is my bill of material. Give it a second. Open with Atom. It's opening up. There it is. It actually, when Atom opens up, it opens up all the ASCII files in the folder. As you can see, it opened the other one as well. So we have our bill of materials right here. So bill of materials. So it does categorize the bill of materials by values, as you can see. So it lets you know that I have 10 microfarad caps, I have three 1.2 k ohm resistors, and so forth. As you can see, it will do it by values. Okay. This is the bill of material that gets generated. Okay, now we have the other file that gets generated is our pick and place machine. As you can see, this is for the front. So it gives me the name of the component and the X and Y coordinates for each one of them. And then we have any components that are in the bottom, which in this case, we have none of them. Okay, very well. Now, with all the files created, here we have our drill files, which in this case, it's only vias going from the top layer to the bottom layer. And then here's all of the Gerber files, your Gerber top, bottom, and then you have your silt screens and so forth. So let's take a look at these Gerber files. What is the board house is going to be receiving? What do they look like at their end? So let me see if I could do this really quick. So I'll go here. This is a Gerber Viewer for Mac. It's actually a nice one. You'll find it on the App Store. It's called Cuprum. Jorge, do you have any recommendations for Gerber viewers for? I know for Linux I've used GerV, and for Windows, what's your go-to Gerber viewer?
My go-to is ViewMate. It's never given me any issues. It is the viewer's free, but if you want to like editing capabilities and stuff like that, then you have to pay. For free and open source, GerV is the best thing going, which I've used, but I have had a couple of bugs on GerV, so I don't trust it as much as ViewMate, but I'm good with either one. So I'll typically stick to those.
Okay,
Um,
excellent, excellent. Now, Jorge mentioned something about Gerber viewer with editing capabilities. Unless you're really a board house, I would do my best to stay away from editing because if you're gonna edit anything on your board, it's best to do it on the board. Um, because if you make edits or changes on the Gerber file directly, then you can't track that. You can't track that back to the circuit board itself. So only do that for extreme measures. Let's say, for example, you don't have the board file or something like that, or they only provided you the Gerber files or something like that. Then you may, but I would stay away from that. Gerber viewer it can be a little bit dangerous. Okay, so if you need to make changes, actually do them in Eagle or in Fusion 360. So let's go ahead and load my Gerber files that I just created. So I'll click here on import and I'll select the file. It's under Eagle, my projects, um, and it's my two-layer example and my cam outputs and my Gerber files. I want to bring in all my Gerber files, only their content. Okay. Turn off the grid. Okay, there we go. So here we have our top copper. I'm just rearranging the order here and my bottom copper. And then you have your solder paste and your board outline. So this is what our Gerber file looks like. So let me just turn off some of these layers. I'll turn these off here. Okay, so you have your top layer, which is all of your pads and your vias, anything that has to do with copper. And then you have your polygon pour, as you could see here. So this is what my top copper is going to look like. And then we could go here and deselect, and we can see the bottom look like. Okay, so I combined them both by mistake. Okay, and there's my bottom. So as you can see, it's pretty much consistent with what I'm actually that I saw in Eagle directly. I'll go ahead and try to import the drill file as well. So let me see if I can do that. The drill file. Drill file usually is right, and as you can see, it's not hollow. I mean, I guess I could change the color of this layer here, which is representing the holes, which is this layer right there. I guess I could change that, maybe the black, that way it matched back, that way it actually looks like a hole. But as you could see, all the holes are spot on, and the dead center are all of the pads and the vias as well. Okay, so this is one way that you could actually, visually verify what what your Gerber files are going to look like. Okay, now that we're done with this example, oh yeah, somebody made the comment about looking for a Gerber viewer for Mac. So
Yeah,
yeah,
and
Copeland works really well.
yeah, one thing that I also wanted to mention, that this is a key step. At the end of the day, you're responsible for the quality of your data. If something happens and boards come back and they don't work, if there was a mistake in the Gerbers, that's on on you at the end of the day. So it's always worth the extra time to run it through a Gerber Viewer, make sure there's nothing unexpected, because the board house is just going to manufacture what you send them. Most good board houses, if they see something odd, will usually contact you. Um, but again, their responsibility is just to make whatever you send them. So if there's any issues there, at the end of the day, it falls back to the designer.
Excellent. Thank you, George, for that. Appreciate it. It's very true. It's one step that you could just it's a small step, and it doesn't really cost you a little bit more than some time to avoid maybe a whole respin run or something like that. You never know what you catch up here. Now, I want to make one observation because some people may be confused. Just in case, the solder mask is that material that is going to be covering your entire board, protecting all of your traces and all your connections. It's going to protect it, but it's going to be exposing all your soldering points, everything where all the components are going to be soldered. The way Eagle exports that file, actually, I think all applications do it, not only Eagle. The way they do that is that they provide a negative image. So let's see how that looks like. So I'm going to turn off the copper layers. And I'm going to turn on the solder mask layers. Okay, as you could see here, what we have is what we have is that it's only showing the whatever's going to be exposed for copper. This is a negative layer. Think about it. It's a negative layer. So everything that's copper is being exposed. So these are all exposure. Everything that you see black that matches the color of the background, that's actually that green material, or if you select any other color, but it's that green that is going to be protecting everything else on your board. Okay. So it's a negative image, just to let you know. So the same thing we have for the bottom as well. Okay. Okay, so I just wanted to bring this up because sometimes we've gotten some back in the day we've received some comments that they weren't sure what was going on because it looked wrong. So now let's move on to another example. Okay, so I'm gonna go ahead and close this one, and now let's go ahead and take a look at a 6 layer board configuration. So I'm sorry, a 4 layer board. So let me just go ahead and load this board what we have here as an example. Load the board as well as the schematic. Okay. As you can see, this example is a little bit more complex. This one is a 4 layer board with way too many polygons. No, that's not true. Yes, it has a whole bunch of polygons, as you can see. I'll go ahead and rat snest that way you can see it. Um, Jorge, I still I keep that old school mentality. I usually don't calculate my polygons because it really slowed down the computer back in the day. Now with these fast speed computers, it doesn't really affect it that much. But that's why I always avoid calculating my polygons that way. It just
Yeah.
doesn't slow it down that much.
Yeah, but even now visually, it's like it can be jarring. So that's, even if performance isn't a problem, to the eye, it becomes a lot of clutter. So for most cases, we recommend keeping them uncalculated, and you
Yeah,
only calculate them when you want to verify that everything is okay.
yeah, when you need
Um,
to.
yeah,
Mhm.
because otherwise it becomes difficult to route in the middle of all this wash of color.
So just to show you how you uncalculate your polygons, that way they go back to their outline format. What you do is that you click here where it says rip up right there. And then on the action toolbar up on top here, where you get all the options. Remember, when you activate a command in Eagle and there's options actually show up, they're going to actually be showing up here. That's where they always show up right here. Okay. So the last option right here on the rip up says all visible polygons. It's going to get rid of them. It's not going to delete them. It's just going to get rid of them. That way they go back to the outline form. As you can see, polygons, when they're in the outline form, are visually identified by those little hatch marks that you see there, those hatch lines. Those are the different polygons. As we did earlier, the first thing I like to do is let's take a look at the DRC. That way we could see what our layer stack looks like. So I'm going to go ahead and click on DRC. Notice that we have a 4-layer board, is what we have here. And this board actually has a little bit of a stack up, um, which is a little bit more elaborate than the previous example as we did. So we have vias that are traveling throughout the entire board from top to bottom, and some blind vias that are traveling from the top layer into one of the inner layers. And then we actually have also some buried vias, which are traveling from between the internal layers, between 2 and 15, as we can see here. Remember that you're always going to be working from the outer layers to the inner layers. Okay, so it's always, so you could see it's like a sandwich working from the top to the middle. Okay, so that's all I really wanted to pick up from here. Everything else was pretty straightforward. You could always run it, which you should be running persistently while you're working on your board. You should be always running DRC every so often. We strongly recommend it. I do have some air wires here, and it's quite possible I do have air wires because the polygons are not calculated right now. Okay. Here's my blind via. It's giving me some blind via errors as well. It's because they're not connected to anything. And I think I have a violation on the whole size as well for the ratio. And I do have some overlap errors here. Oh, these were actually intentional. That's just for a component to just, yeah, it's kind of like a thermal, so they dissipate heat faster. So this is kind of fully acceptable. So I could accept all these for here. That's fine. Now that we have that, now let's go through the CAM processor process. Now, instead of using OneClick, I'm going to use the CAM process. Oh, let's take a look at manufacturing before we go there. You can see what the board is going to look like when I receive it in the mail. I don't know why, but it's like Christmas every time I get boards in the mail, George. You know, that envelope, and it's kind of rigid, it's kind of hard there. It's like, oh, got my boards back. Going through some reflow style. We'll talk a little bit about reflow. What is that you're going to be using for reflow? Talk about that in a minute. Okay. Now you could execute the CAM processor from right here as well. I could use the menu on the toolbar here, or I could just use it for here as well. So you get your board statistics from right here as well. Your drill file, it says we did earlier today. And here you could click on what says, I'm sorry, gotta go back to preview. That way you get that. Right here, it says CAM, as you can see it right there. I'll use this big arrow right there. That way you can see where it's coming from right there, this CAM. So if you're taking a look at it and you want to go straight to your CAM processor, you could go right here. Okay. Remember that we said that, you want me to save? Yeah, save what I've done so far. Okay, and there's the CAM processor opened up now. Okay, CAM processor, as you could see. I could have maybe used the OneClick, but since this is a bit more elaborate board, there's a chance that I want to have a bit more control of how am I going to be exporting the files. Okay, so that's why I'm actually going to use the CAM processor this time around. So I'll go ahead and click on my Gerber files. As you can see, that's my top side. We do have a preview in the dialog box right here. Let me take a look at what it's going to look like. I could preview it. Also here on the layer list, I could see what layers have been selected to create this Gerber file. So I could actually verify it here and actually kind of preview it there. When the developers directed by Matt Bergren actually added this, it was pretty neat because now you have somewhat of an idea. And this view should be what you be seeing in your Gerber viewer as well. So they should look exactly the same. There should be no difference at all. So here do have an inner layer 2, and this is what inner layer 2 is basically um, kind of a reflection of what's going on the top and the bottom layer for several of the components, which are through hole, and some of our points of transition, our VS as well. This is my inner layer 15, and our copper layers as well, my board outline, my solder mask bottom. Now, let's say, for example, I wanted to um, import, let's say, a logo, and I imported that logo. For Eagle to import kind of graphic files, you should be using a monochrome bitmap file. I mean, it does support 16 layers, but every layer is a different color, so it gets really big. So I like to try to recommend that you only do monochrome bitmap files. Eagle can import those using a tool that we have. And let's say I imported that file and I created a layer 110 called logo. Well, here on the silk screen, you want to enable that layer, or you brought it into another one of our documentation layers that we have available for you by default. So you may have to add, you may have to modify or add or change what layers are going to be used in this process at the silk screen layer. That way my logo will actually show up. The way you would do that is that right here. So let's first show, before I go back there. So let's go here. These are my list of layers that I have. And let's say you added something to here where it says a document layer or the reference layer. I want to add these two layers to my output process. Okay, I'll click there, give it a minute. It's just loading it up. So what I would do is I would go here to my silk screen, as you could see right there. And if I had a logo on one of those other layers, I would click right here where it says edit layers. I would find the other layer I wish to include here. So I have the T place and the T name. And if I have information on the, let's say, the document layer or the reference layer or both of them, I would select, click on one, click on the other one, and click OK. And you could see they're added there, those layers, and it will now include any additional information. And that information will be now part of my Gerber file when it comes to my silk screen for the component side of the board. Okay. So that's why the CAM processor, we we like to use it because we have a bit more control of it. Now let's take a look at the effects that happen on the drill file. You'll notice that on the drill file, it's a little more complex that we had earlier. You'll notice that the file name is drill one underscore two. That's just letting me know that the file that's going to be generated that has the name drill one underscore two are for the vias that have a depth that is going from the top layer to inner layer two. Okay, those vias. Then here we have the vias that are going from layer 1 to layer 15. These are from layer 1 to 16, which are your regular through-hole vias that go from one side of the board to the other side. And then we have our buried vias, which are 2 to 15, you can see here as well. Okay, so instead of having one drill file, we're going to end up having 4 drill files, and their name is going to identify where to go. Okay, let me go back to the drill file because I forgot to tell you a few facts here. If you go to where the setup to generate all this is the setup header right here. You notice that we're using Gerber 274X. We do support X2, but we've had really good luck with Gerber 274X. Board houses kind of like prefer it, but we do have X2. It's letting you know what is the prefix is going to be and what is the format specifier. By default, if I'm not mistaken, we actually use 3.4. So uh, 3 digits for integer and 4 for decimal points. Uh, I'll be really honest with you. It's a big precision, but it works and it's widely acceptable. We just conform to what the majority of board houses use. And for the drill files, our output is Exelon. That's what we're using for the output. And the format specifier is 3.3. That's what we're using. As you can see here as an example how that works.
Yeah, and
Okay, the
this
bill of
gives you the
material, as I said earlier. Yeah, go ahead, Jorge.
yeah, and this gives you the flexibility to adjust in case the board house has some special requirement. We've run into sometimes board houses that want really precise Gerber files where you see extra decimal places and things like that. Those are things that you can adjust here, whereas in the one-click option, all of that's already been specified for you. So you have to kind of keep that in mind and make sure you're aware of what the one-click solution is doing. Because if you're not sure what it's doing, maybe your board house comes back to you and says, "Hey, that something here doesn't look right," and it may be that it's just not this format they're expecting. So it's good to have these options and be aware of them.
Thank you, Jorge, for that. It's a really good point. Excellent. As we saw earlier, we have our bill of material. It's going to be outputted. It's going to be in a text file. That you could change that here by default. To be honest with you, I hardly ever really do. It is going to be categorized by values, so it summarizes the amount of components. You can list them one at a time. And then we have our pick and place outputs for top and bottom here as well. Now, there are some board houses that provide you a CAM file, which you could load in here because they may want to use a different kind of a stack up or a different um, format because that's just what they've found that loads better for them. So the way you would handle that is you would go here where it says right here where it says right there. So you could open up a cam right there, as you could see there. So if you download one from a board house, you would go there and then you could either say save or disregard this setting because since I did made some modifications to it, it wants me to save it. Okay, so I would go there, or we actually have several board house CAM files available based on recommendations by different board houses. So let's go here. So we have one for Volterra. So if you're going to be printing, it's like an inkjet printer with conductive material. You could actually use the CAM file for Volterra. We have some legacy ones. If you're using like a previous version of Eagle, we have those legacy available here for 274X and so forth. We have some third-party CAM files like from OSH Park, from Seed Studios, Eisler. This is, I think they're out of Germany, if I'm not mistaken, and for Beta Layout as well, out of Germany as well. Okay, and these are the different templates we have for 2, 4, 6, 8, up to 16 layers what we support. Okay, as well. And then you just got more templates, and these are some. Oh, I already covered those as well. So that's one way if you want to load a cam job. Let's say you generated the Gerber files for a board some time ago. It's not a bad idea, and you made some modifications to that cam job. Then go ahead and load the same cam job that you did or a couple months ago, whatever. That way you don't have to be setting up those layers again. So if you're consistently using additional layers for logos or for any other information, dimensions or anything like that, keep track of that Gerber file. You may want to actually put it in the Eagle cam directory. That way you could continue loading that one. So you can manually load it. And the way you would load it is you would click here, a file, which is drop down here, file, and then open and select the cam job file. So now let's go ahead and process our job. Now that everything has been pretty much set up. And I'm not selecting zip, so I'm not going to compress these files because I may want to just prefer to just upload them directly to a website, and they don't want them zipped, so I'm not going to zip them up. And it kind of defaults to put everything in my project directory. So I'll click on process job. It's going to ask me, where do I want to put the files? I'll tell it to put them right there. Yes, you want me to replace them? Yes. Okay. All the files have been successfully created. So I'll click OK. Not sure how do I do on my Mac that way. I don't know why the CAM processor, every time it opens up a new Finder, it always opens it up on a different screen. Um,
That's what happens when you have multiple screens, Ed. You get confusion.
yeah, no, but yeah, it's the only time I do. I love my screens. Our eternal debate, one screen. Okay, very well. So all the files, as you could see, these were my board and my schematic files. Just to let you know, these $1, $2, and every time you save, these are backup files. So it's constantly doing backup files. It does up to number 9, and then it comes back and it keeps on doing it all over again. If you ever want to need to recover, you just rename one of these files and look at the timestamps. That way you know which one you want to recover from. Okay, so let's take a look at the CAM outputs. As you can see, let's take a look at the Gerber file first. So we have our job file, which is here, right here. Here's the job file that we see right there. That's the job file right there. Okay, then we got our copper layers, all 4 of them, top, bottom, and our inner layers, our silk screen, and our solder mask layers. Perfect, just like we did earlier. The drill files is going to be a little bit different here. It's going to be a little bit different. Instead of having one drill file, you notice that we have four of them now. So because since we had different depths defined, so we got from 1 to 2, 1 to 15, 1 to 16, and 2 to 15. So just because I have different layer depths. Now, unless you really, really, really need the real estate space, kind of stay away from these using blind buried vias because that exponentially increases the price on your board, just to let you know. Okay. So I would stay away from that. And then again, as we showed on our one-click solution, we got our bill of material as well as our the information for our pick and place for our top or our bottom. I used to open one of these up, see if Adam. I still have Adam still available. Yeah, I do have it available. So there we go. There's my bill of material. This is for my components that are located on the back side, my pick and place, and here are the ones that are located on the front side of the board as well. It's kind of a dense board. So this was all of the material I wanted to actually cover for the webinar. I went over a little bit the time I wanted to spend here. Sorry about that, guys. I was hoping to really do it in 30 minutes, but as always, I go just a little bit over. So if you have any questions, please go ahead and visit us on the forum on our Autodesk Eagle forum, and we'll take care of your questions there. And if you have any interesting topics that you'd like us to cover, let us know on the forum as well. What do you think other topics that we should be covering? I'll be back on Thursday. I think we're doing libraries on Thursday. I'm not really sure, but we'll be back at 2 o'clock at 2 p.m. Eastern time. Everybody, thank you for joining us. It's been a pleasure. Please stay safe. You know, um, take care of yourself. Let's respect the social distancing and stay well. And Jorge, thank you for being here and your support as well, and taking care of the guys on on the chat here on YouTube. Everybody, have a great day.
Everyone, have a great day. Hey Ed,
Yeah.
one of our users here, Fox Sabilo, he put a little comment that was interesting. He says to give people an idea of how much buried vias cost. He says he had a 16 layer board that was priced at 78 cents per board at 10,000 quantity. So in other words, 10,000 units, 78 cents a unit without blind vias. With blind vias, the board was $11 each at 10K.
Wow. Okay. So thank you for that example, Fox. It really puts the point across about trying your best to avoid them. It might be better. Well, depending on the enclosure, might be better to make a slightly bigger board. Absolutely.
Yeah. I mean, you take it into account, how much and what the product needs. But yeah, definitely if you can avoid it, oh yeah, avoid it. That's like 12 times more or less.
Oh no, yeah. If you round it off to $1, absolutely, sure thing.
Yeah.
Thanks for that, everybody. Have a great day.
Bye everyone. Have a great day. Take care.